I will demonstrate the basic functions of ChemDraw. First, open ChemDraw. An untitled document will appear. Now on yours, you may see some toolbars already here. I have them all turned off so that I can show them to you at appropriate moments throughout the tutorial. Let's go ahead and introduce our first toolbar. Under View, we'll show the main toolbar. This contains all of the drawing elements that you'll need to draw basic structures. I'm going to draw diethyl ether. Notice that I'm clicking on the center of the bonds and it sets the geometry for me as I use this line tool. I can double click to type, or I can use the A, which will give you text. And you'll notice maybe in this structure that the oxygen atom is proportionally quite small to this bond length. Fortunately, ChemDraw has templates for us that have a little bit nicer of settings. So let's go ahead and open Stationery, and the one I like to use is this ACS document 1996. A new document will open, and let's go ahead and try to draw ether again. Notice that I can actually click on here and drag, but I can kind of distort the bond angle, so I'm just going to undo that and continue with my clicking method that draws my very good bond angles. When I introduce the oxygen atom, I can see proportionally the structure is a little bit better. Now, this view is a bit small, so we'll get to how to make this a little bit easier to see in just a moment. For now, I'm going to close this document and I'm not going to save it. What I want to show you is, in our original document, we had different settings applied, so our structure looked a little bit funny. Well, I could always open my new Stationery. However, if I get going with a project and then realize it's not in the settings that I want, I'd like to show you how to change that as well. So let's go over here, document settings, and we can apply document settings from any of these documents. It's going to ask me if I want to modify the existing, and I do. If I don't modify the existing structures, this one will stay in these proportions. And then everything else I draw beyond that will be in ACS settings, but the original structures on the page will not. So modify existing, and you can see it's kind of taken the size down a little bit and change the proportions. Now, this is a little bit difficult to see, so let's introduce a second toolbar. This is the General toolbar. Truly, it contains everything in the File menu, and most of these things can actually be done with shortcuts, key shortcuts. For example, Save, Command Save will save. So here's a new document. Here's opening a folder, saving, printing, undo and redo, cut, paste, clipboard, but these things are most readily done, I believe, with key commands. So learn your key commands. The one thing that I do use on here a lot is the zoom of the screen. We're at 100% right now. I'm going to just bring this up to 150, and you can see that we're doing a little bit better with how well we can see this structure. Now I'm going to go ahead and add a molecule to my image. And so I can click on this bond again. I can go to my text tool here and introduce an oxygen atom, or I can always double click and put a hydrogen atom. I'm just trying to draw water here. Now I'd like to show you one more trick while we're using the text tool. If you are actually in the text tool, you can highlight something that is already an atom label that you would like to repeat. Go to your new bond where you want it and double click, and it'll introduce whatever that group is. It can be as simple as H, it can be O-benzyl, it can be a long abbreviation if you want it to be. So just whatever is highlighted will duplicate at the end of that bond when you double click. So it's a very nice trick. And if I keep doing that, we'll put H's everywhere, but of course we don't want to do that right now. So these two structures, if I wanted to select them, I could use the selection tool. You actually notice when you click on that, the last thing that you've drawn that is a structure does get highlighted. But if I want to highlight both and I'm taking a wide area, I can use this marquee tool to kind of just get everything in there. But say I want to select this water molecule and it's kind of close, and oh, I just keep getting this little piece of this molecule and I don't want that to be moving around with me. What I'm going to do is use the lasso tool, and I can easily draw a line around this and select it separately or select a portion of the molecule. Here, this changes the perspective of the structure. We're not going to get into that right now. We'll do that in a more advanced lesson. We're also going to skip this fragmentation tool. This is for doing retrosynthetic analysis, and that's not a basic tool. I actually have never used it very much, but can show you how in a later version of this. So here's just an eraser. We've gone into the line tool and kind of how to use that. Clicking on the bond itself will actually give you the best bond angles. So it's good to let it kind of draw itself if possible, but you can always click and drag and put your bond wherever you want. And actually, this will make a double bond if you drag it over an existing bond like this. And there are other ways to make double bonds. So let's go ahead and use some of these multiple bond tools. I'm going to start by just drawing a double bond. And now I would like to show cis-butene. I'm going to click on this and it sets my bond angle. Now I click here and I have my cis-alkene. These are on the same side, also called a Z-alkene. So our groups are on the same sides. These are H's pointing down. Those are implied. Now I want to draw an isomer of this, trans-butene. So I can go ahead and select my double bond, or if I'm in the single bond tool, I can just click on the center of my bond. I'll click here, and oh, it gave me the cis one again. If I undo any motion that I've done and the bond angle was drawn in the opposite direction that I want, if I just Command Z, when I click the second time, it'll do it in the opposite orientation. That's a very nice feature of ChemDraw. So here we have the cis compound, and here we have the trans. Now these are just isomers of each other. They have the same 1, 2, 3, 4 carbons, making them 2 butenes. However, I want to show you some other bonds that I can use to kind of express these structures as mixtures and things like that. So any of these tools can actually be dragged out, these toolbars, and then they can just be closed later. So if you're working with one of your toolboxes extensively, it might be nice to pull it out. So if we want to express this as a mixture of cis and trans, so I'm just using my marquee, I'm going to copy and paste this structure. I could, of course, do that with the menus. However, key commands are so much faster. This means double either. So if I want to express both of these structures in one form, then I can take this, click on the center of the bond, and it does this little X bond. Now, there's a program for structure search called Reaxis that often uses this notation, so it's good to know it. Another way, if I just want to show that this is either bond again, and I'm just arbitrarily using my trans alkene to demonstrate this, I can also use a bond tool over here, the squiggly bond. And this wavy bond might show that this is a mixture, that it goes in two directions. So these are both ways to kind of express the same thing with this bond, that we're showing that it's a mixture of these two compounds, that it's not just purely cis or purely trans. So this is the cross bond, and then this one is the wavy bond. So let's look at these a little bit more. We have triple bonds, quadruple bonds. This I haven't used very much. It's a dative bond. It kind of shows where the electron density lies. You can use it for a sulfur-oxygen bond. However, the regular bond tools are just fine for that. Here are some different dotted bonds. This one we're going to get into in a little bit more advanced lesson. Now, these tools down here I have never used. This is just to show that this could be any bond here, double, single. I've actually just never seen these labeled. If we want to show this, oh, instead of any, single, double, single, or any, but really these are not conventionally used, so I would just kind of skip them. All right, so good bonds to know for now are double, either, triple, quadruple, and we'll get to dotted in a little while. So I would also like to show you some of these other bond tools that are here. We have the dashed bond. So let me just move this guy. Let's say I want to show an interaction of two water molecules in a hydrogen bond. Well, I can copy paste this structure, move this guy into a relatively nice position, and now I can take my dotted bond, and if I want to show this hydrogen atom is in a hydrogen bond with this oxygen, I can go ahead and just draw a little dotted bond there, and that'll show that for me. Go ahead and briefly show you the pen tool. I have used this once to draw a titration curve. The pen tool can be used to create curves. So as you're drawing with this, it'll kind of, you notice it's smoothing out your line. So if you choose this first piece under the pen tool, say I want to try to draw a titration curve freehand, well, that looks pretty decent. However, there's another one that allows you to set points, and then you can kind of curve along the points, and now I could set another point and curve that. Again, these are fairly difficult to use. I haven't had very good luck with them, but I at least wanted you to know what they are. We have a variety of bonds here to indicate stereochemistry, so I'd like to introduce a molecule that has stereochemistry. And let's do something simple, an amino acid. So I'm just going to start clicking to draw. I want to make a carbonyl, and so I can just double click in the middle of my bond. I could use the double bond tool. I could use the A to do some of my labeling, or I could double click on the end of a bond and get my typing tool to come up as well. So that's what I'm doing, just double clicking. And we want an R group here and an NH2 on this side, so that's looking good. And the amino acids that are common in your body are L amino acids. D amino acids are fairly rare. I guess they've been, there's some in some bacterial envelopes, but nothing in us. So what I'd like to do is change this into the stereochemistry that is naturally found in our body. This hashed bond indicates stereochemistry. If I click on this bond, it will change into the hashed bond. Now, there's two types of hashed bonds, and some people prefer one or the other. This one kind of makes it look like it's coming out at you. You can see it's kind of tapered. Now, some people argue, well, it should be tapering in the distance, and so you click on this, and this will make it taper in. However, you know, just to avoid that ambiguity, I like to stick to the bold ones. They're just straight lines, and so I don't know if it's, you know, tapering as it goes back or coming out as it goes back, and I don't have to worry about that. So I prefer to use this one and this one. And this would mean it was coming out at me, but we're showing this coming back in this particular structure. I'm going to double click here, and I'll just write out my methyl group. Oops, let's do that right. You'll notice that it automatically went to a formula mode, and so when I typed my CH3, it made the 3 small, and that'll usually happen when you're typing on the structures themselves, and I'll show you a little more of how we can play with that as we get into this tutorial. All right, so here we have our amino acid, and what I would like to do is show its mirror image. And so if I just copy and paste this, I could redraw it showing the mirror image. There are 2 ways to express it. But to show the mirror image, I can change this bond. Okay, this is the enantiomer. So what I'm saying is this carbon in space really exists with this group always coming into the page. This one is coming out at you. Okay, and so they exist purely in one enantiomeric form. This one by itself or this one by itself. Now, I could also draw this acting like there's a mirror plane right here to show the mirror image. Okay, so this is one way to express it. But I can also go into the object menu and do some flipping. Okay, now I want to just show you if I flip this horizontally, the stereochemistry stayed down. Now, if I were to actually, in my mind, flip this over, this CH3 would be coming up. If I orient these molecules so that the OHs are on the same side, this should be coming up. So using that flip tool really did show me the enantiomer, and this is the same as this structure, okay? But this one right here is different from these two. It is the opposite configuration at this carbon. Now, I want to show you another way. Let's just undo what we did, okay? Now, say we're thinking we want to make the enantiomer, and instead, we rotate it instead of flipping. Notice that it actually rotates the group for us. Now, these are the same molecule. So we've actually, when we rotate it, it rotates all the bonds for us. So if you have something in the configuration that you want, it's really nice that ChemDraw will do that for you. Just make sure that you're using the difference between flip. Flip just flips the structure as you've drawn it with the drawing elements in the orientation that you've done them. Rotate does rotate around the bonds and will preserve your stereochemistry. I'm going to get rid of this structure because I'd just like to show my two enantiomers and do some comparisons with them. Now, if I would like to show this as a mixture, say I don't have one of these in my solution, I have a bottle with a mixture of these two amino acids, I can just take this, and here I'm trying to express a mixture of the two, so I can use, again, my wavy bond to show, oh, this is a mixture, some of it's up, some of it's down, it's not in pure form. This, so let's just label these up a little bit. This would be the L, and this will be D-alanine. And here we have racemic alanine. Okay, it's a mixture of the two. Sorry about that. Okay, so this is how we show each enantiomer separately. This is how we show the mixture. We do have orbital tools, and so if I wanted to draw an orbital on, say, my oxygen atom, I could do that. Clicking and dragging before I release will move it around, and I could draw an orbital for this pi bond. Okay, so that's always a possibility. Here we have some drawing elements and these brace tools. Right now I'm going to come back to these. These can be used in many ways to make your images look nicer, to make separation, and this can be used to show transition states and things like that. But we're just going to skip them for right now. So I would like to show you actually the chemical symbols tool, and that guy is right here. Here, let's pull him out for a minute. We have our positive and negative charges expressed in two different ways. Here's a radical cation, a radical anion. You may or may not know what those are at this point. We can show lone pairs, radicals. This is a way to show that a hydrogen is coming up out at you in a tertiary center. This shows it dashed down. These tools are a little bit different. You can use this to show the structure is cut off, maybe attached to a resin, and things like that. What I would like to show you is how these amino acids can be converted with this tool into their zwitterionic form. Now, amino acids in solution in your body do not exist like this. The carboxylic acid is sufficiently acidic that it gives up its proton, and the nitrogen here is sufficiently basic that it accepts that proton. Well, ChemDraw can be very smart. And so what we do is say we want to show this as its charged species. I can simply click on the nitrogen, drag to where I think my positive charge looks best. Notice it changed this number for me. Here, let's undo that and do that one more time. Keep watching this number right here. Bam. So this program knows that when nitrogen has 4 bonds to it, that's when it's positively charged. So when I put the positive charge on, it added that extra hydrogen for me. It can be very convenient. Here, I put the negative charge on, and the hydrogen goes away. So that's very neat. Now I would like to show you just a little bit more with this. I want to introduce the chemical warnings, and these are right here. So nothing came up, so that's good. Tells us our structure is good. If I made a mistake here and I was typing and I did NH3 instead of NH2, a box will come up around this, and that's letting me know that I've actually drawn this with the wrong valence. Now, if I just meant to make the Zwitter ion and I was doing that part first, it'll go away when I add my charge on appropriately. So that's good to know. You can leave your chemical warnings on as you're learning. I would just like to show you the radicals and how these work. So I'm going to show you an allyl radical. It's a pretty stable radical. I don't like that bond going in that direction. I want it to be flat, so I'll just put it here. It makes not a big difference. But we can just take this carbon and put our radical on wherever we would like it to be. So this means this is a carbon with 3 bonds and 1 single electron. This can be used to show a lone pair. Let's go ahead and just put some lone pairs on our oxygen atom. You see I can kind of drag in position, but now they're associated with that. You can put them on here. We would have to put 1, 2, and 3 because this one has 2 bonds to it already, and so it has its 2 unshared pairs of electrons, but this one has a negative charge, therefore it has 3. Okay, I've put away my symbol tools, and let's go ahead and get into these query tools just a little bit. This A to A is useful for mapping reactions. We can do it to kind of map atoms on our structures here. Now say I want to show that this oxygen atom corresponds to this same oxygen atom. When I do that, it'll set numbers and actually does a pretty good job of where in the structure other things should be. So we can number these, and then if I want to make this one come up bold, there it goes. So I think this is a little less useful when we're just showing structures, maybe a little bit more useful to map in reactions to show which groups are being changed into what. This can be here to show a chiral center. This is the asterisk is a very common tool used to show a racemic mixture, so we can do that there. Now we have this tool I've never used and I don't know how to use it, so I won't be showing you that today. We have a few things, a few labels. These are just labels: racemic, absolute, and relative. Okay, that's what these stand for. These are stereochemical markers. Now, something like L-alanine has absolute stereochemistry. What I said about this is that this is really facing down in toward the page. This one is truly coming up at you, and you don't have a mixture of the other enantiomer in there. So for both of these, I could use this label and say this is absolute stereochemistry. Now this one is the racemic mixture, and so I could label this one as racemic if I want to. So these are just really tools to show you the stereochemistry. Relative, this is a little bit more advanced, and so we won't get into that in this lesson. Here is a tool to make matrices and TLC plates. We will not get into that right now. I will do that in a later lesson. The sequence tools are kind of fun if you're going to be drawing sequences of long chains of amino acids or DNA and RNA. All right, so I want to show a chain of single letter amino acids. I will have to know my 1-letter codes to do this. But if I click, I can go show some amino acids in order, and it'll show from the NH side to the carboxylic acid side. So that's lysine, K, glycine, cysteine, phenylalanine. Now let's go ahead and show this. This is the 3-letter code. You still need to know your 1-letter amino acid codes. But when I type K, it's going to show me lysine. Now G, glycine, C, cysteine, and F again, phenylalanine. So this is kind of nice if you want something a little bit longer. If you're doing long chains of code, this probably is ideal. We can also draw DNA and RNA chains. So G, C, T. Oh, let's try U. Oh, invalid hotkey. Of course, that's only an RNA. So you have to use the correct symbols in here or it'll stop you. So you can do sequences from the 5' to 3' end of DNA as well. kind of a neat tool. Let's get into drawing some chains. So this is the chain tool, and I'm just going to show you one of these. The thing that this does is when you click and drag, it counts carbons for you. So say I want to draw a fatty acid. In specific, a saturated fatty acid, let's say stearic acid. So that would have 18 carbons. So I'm going to click and drag until I get my 18, and now I can be confident because ChemDraw counted for me. Now that I have my 18 carbons, I'll go ahead and put my carboxylic acid on here. And bam, stearic acid. So that's pretty useful. I'm going to show you how to use some of these ring tools now. These templates we'll be skipping until a little bit later lesson. But these are all just, representing cycloalkanes. And so we have a cyclopropane, cyclobutane, cyclopentane, and so on. Let's just look at how these work a little bit. So here's a cyclohexane. If I want to make cyclohexene, I can put double bonds in it. If I want to make other compounds that have, more elaborate ring structures, I can do that too. If I click on one of these corners, I make what is called a spirocycle, where this is just attached twice at the one carbon. But using this, we can also make fused rings. So notice I clicked on the center of the bond there, and now we have this decalin. Here is some aromatic rings. If I add another one on, it adjusts the bonds for me, and I've drawn naphthalene in just an easy step. Here, we can use this cyclopentane, and we can just use our text tool, put a little O in there, and this is a common solvent that we used in the lab, tetrahydrofuran. So these tools are really useful for quickly building up structures. So I'd like to go ahead now and introduce the object, one more toolbar, and that is going to be our object toolbar. So now that we have a few things on our page, we can actually use this. This is really just an organizational tool, so I can shift and select. I can, use my marquee. Oops, I've selected some of that. Maybe it's better to use my lasso. I can do that, okay? But either way, I want to select these, and I want these to look a little bit better, better aligned. And so what I can do is pan over some of these. I can align my left edges of them. That's not exactly what I wanted to do. I wanted to align the top and bottom. So here, let's align the top edges, align the bottom edges, and then this is to align the middles of structures. Sometimes you'll have a structure. Let's do something here to show this. Let's show two aromatic compounds. So here, let's show anthracene. This is an anthracene molecule, and we're going to show actually furan. Okay, now say I feel like these should be aligned in the middles, okay, and so this will align the top and bottom centers. You see that? So let's just undo that and show you one more time. If I align the middles, boop, they're on top of each other. Okay, so that's good for aligning in a vertical fashion.